In this tutorial, you are going to learn how to do sentiment classification with Tensorflow 2.0. Let's get started. Before we begin, a couple of notes. First of all, it would be very helpful if you have already seen my previous video on doing word embeddings in Tensorflow 2.0, because we're going to be borrowing heavily from the concepts I presented in that video. If not, it's not a huge deal. I'll show you everything we need to do as we go along. It's just it'll make more sense with that sort of background. Second point is that I am working through the official TensorFlow tutorials. This isn't my code. I did have to fix a couple of bugs in the code, so I guess that makes it mine to some extent. But nonetheless, I did not write this, so I'm just presenting it for your consumption in video format. Third point is that my new course, Deep Q Learning from Paper to Code, is on sale for the next several days. Hit the link in the description and or pinned comment to get it for $9.99. And I'm also working on a new course on actor critic methods, and then there will be courses on natural language processing and pretty much every other topic after that, so stay tuned. All that said, let's go ahead and get to coding our sentiment analysis software. So as usual, we begin with our imports. We will need the TensorFlow datasets to handle the data from the IMDB library. Of course, you need TensorFlow to handle TensorFlow type operations. So the first thing we want to do is to load our dataset and get our training and testing data from that, as well as our encoder, which I explained in the previous video. So let's start there. Dataset and info is load of the IMDB reviews. Help if I spelled it correctly. Subwords 8K. Now, just a word, these are the reviews, a bunch of reviews from the IMDB dataset. So you have a review with an associated classification of either positive or negative. With info equals true, as supervised equals true. Tab that over. Next, we will need our training and testing data sets. Set equals data set sub train and data set sub test. And finally, we need our encoder. Dot encoder. Good grief, I cannot type tonight at all. So if you don't know what an encoder is, the basic idea is that it is a sort of reduced dimensional representation of a set of words. So you take a word and it associates that with an n-dimensional vector that has components that will be non-perpendicular to other words in your dictionary. So what that means is that you can express words in terms of each other, whereas if you set each word in your dictionary to be a basis vector, they're orthogonal, and so there's no relationship between something like king and queen, for instance. Whereas with the autoencoder representation, the word embedding representation, it has a non-zero component of one vector along another, so you have some relationship between words that allows you to parse meaning of your string of text. And I give a better explanation in my previous video, so check that out for your own education. So we're going to need a couple of global variables, a buffer size 10,000, a batch size for training, and some padded shapes. And this is for padding. So when you have a string of words, the string of words could be different lengths. So you have to pad to the length of the longest review, basically. And that is batch size by empty. So the next thing we'll need is our actual data set. We're going to shuffle it because we are good data scientists. And we're going to want to get a padded batch from that in the shape defined with the variable above. And the test data set is very similar. Good grief. So I'm using Vim for my new text editor, part of my New Year's resolution. And let's yank that, and it is a little bit tricky if you've never used it before. I'm still getting used to it. There we go. As you can see, then we have to go back into insert mode, test dataset dot padded batch, and padded shapes. All right, that is good. Next thing we need is our model. So the model is going to be a sequential Keras model with a bidirectional layer as well as a couple of dense layers. We're going to use a binary cross entropy loss with an atom optimizer learning rate of 1 by 10 to the minus 4. And then we will say tf keras.layers embedding encoder.vocab size 64 tf keras layers bidirectional tf keras.layers.lstm 64 two parentheses dense, and that is 64 with a ReLU activation. If I could ever learn to type properly, that would be very helpful. Another dense layer with an output, and this output is going to get a sigmoid activation. And what this represents is the probability of the review being either positive or negative. So the final output of the model is going to be a floating point number between 0 and 1, and it will be the probability of it being a positive review. And we're going to pass in a couple of dummy reviews, just some kind of softball kind of stuff to see how well it does. But before that, we have to compile our model, and with a binary cross entropy loss, optimizer equals tf keras optimizers atom learning rate 1 by 10 to the minus 4, and we want metrics accuracy, and then we want the history, which is just the model fit. And this is really for plotting purposes, but I'm not going to do any plotting. You get the idea that the accuracy goes up over the time, and the loss goes down over time, so no real need to plot that. Train data set. We're just going to do 3 epochs. You can do more, but for the purpose of the video, I'm just going to do 3. Actually, let's do 5, because I'll do 5 for the next model. We're going to do validation data equals test data set, and validation steps 30. So next we need to consider a couple of functions. So one of them is to pad the vectors that we pass in to whatever size, and the second is to actually generate a prediction. So let's define those functions. And just to be clear, this is for the sample text we're going to pass in, because remember, the reviews are all of varying lengths, and so we have to, for purposes of the, I guess you could say, continuity of inputs to your model, and not a really technical phrase, but so that way you pass in the same length of vector to your model for the training. We have to deal with the same problem with the sample text that we're going to pass in, because we don't have an automated TensorFlow function to handle it for us. And we're going to pad it with zeros, because those don't have any meaning in our dictionary. And we want to return the vector after extending it. So if you're not familiar with this idiom in Python, you can multiply a quantity, like say a string, by a number to basically multiply that string. So if you had the letter A multiplied by 10, it would give you 10 A's. And you can do that with list elements as well. Pretty cool stuff. Neat little feature of Python. Little known, I think, but that's what we're doing here. So we're going to pad the zeros to the size of whatever size we want, minus whatever the length of our vector is, and extend that vector with those zeros. Next, we need a sample predict function. And the reason we can't just do model.predict is because we have the issue of dealing with the padding. Text equals encoder.encode. And remember, the encoder is what goes from the string representation to the higher dimensional representation that allows you to make correlations between words. So if you want to pad it, then pad to size, encoded sample pred text 64. That's our batch size, or our max length, sorry. And then encoded sample pred text equals tfcast flip 32, and predictions model.predict if.expand dimensions encoded sample pred text 0 on the batch dimension, return predictions. All right, so now we have a model that we have trained once we run the code, of course. Now let's come up with a couple of dummy, simple, very basic reviews to see how it scores them. So we'll say sample text equals this movie was awesome, the acting was incredible, highly recommend. Then we're going to spell sample text correctly, of course, and then we're going to come up with our predictions equals sample predict sample text pad equals true, and we're going to multiply that by 100 so we get it as a percentage. And I can't quite scroll down. That is a feature, not a bug, I am sure. You can write in whatever positive review you want. So then we'll say print probability, this is a positive review, predictions. And I haven't done this before, so when I coded this up the first time, I have it executing twice, once with pad equals false, once with pad equals true, to see the delta in the predictions. And surprise, surprise, it's more accurate when you give it a padded review. But in this case, I'm going to change it up on the fly and do a different set of sample text and give it a negative review and see how it does. This movie was so-so. I don't know what this is going to do. That's kind of a, vernacular. I don't know if that was in the database, so we'll see. The acting was mediocre. Kind of recommend. And predictions, sample predict, sample text, pad equals true, times 100, and we can yank the line and paste it. All right. Okay, so we're going to go ahead and save this and go back to the terminal and execute it and see how it does. And then we're going to come back and write a slightly more complicated model to see how well that does, to see if adding complexity to the model improves the accuracy of our predictions. So let us write quit. And if you've never used Vim, you have to press :WQ. Sorry, when you're not in insert mode, write quit to get out. And then we're going to go to the terminal and see how well it does. All right, so here we are in the terminal. Let's give it a shot and see how many typos I made. Ooh, interesting. So it says, check that the dataset name is spelled correctly. That probably means I misspelled the name of the dataset. All right, let me scroll up a little bit. It's IMDB reviews. Okay, right there, dataset. Yeah, you can't, yeah, right there. Okay, so I misspelled the name of the dataset. Not a problem. Vim tf sentiment. Let us go up to here. IMDB, right quit, and give it another shot. I misspelled dense. Okay, can you see that? No, not quite. It says here. Let me move myself over. Has no attribute dense. So let's fix that. That's in line 24. Line 24. Insert an S. Quit and try again. There, now it is training for 5 epochs. I am going to let this ride and show you the results when it is done. Really quick, you can see that it gives this funny error. Let me go ahead and move my face out of the way. Now this I keep seeing in the TensorFlow 2 stuff, so as far as I can tell, this is related to the version of TensorFlow. This isn't something I'm doing or you're doing. There is an open issue on GitHub, and previously it would run that error every time I trained with every epoch. However, after updating to I think TensorFlow 2.1, it only does it after the first one. So I guess you gain a little bit there, but it's definitely an issue with TensorFlow. So I'm not too worried about that. So let's go ahead and let this train. All right, so it has finished running, and I have teleported to the top right, so you can see the accuracy. And you can see accuracy starts out low and ends up around 93.9%, not too shabby for just 5 epochs on a very simple model. Likewise, the loss starts relatively high and goes relatively low. What's most interesting is that we do get a 79.8% probability that our first review was positive, which it is. So an 80% probability of it being correct is pretty good. And then an only 41.93% probability of the second one being positive. Now this was a bit of a lukewarm review. I said it was so-so. So a 40% probability of it being positive is pretty reasonable in my estimation. So now let's see if we can make a more complex model and get better results. So let's go back to the code and type that up. So here we are. Let's scroll down and say, let's make our new model. So model. You have to make sure you're in insert mode, of course. Model equals TF keras sequential TF keras layers. Of course, you need an embedding layer to start. Encoder.vocab size 64. Let's move my mug like so. And add our next layer, which is keras layers bidirectional. LSTM64 return true, and I am way too far over. 88, that is still, well, we're just gonna have to live with it. It's just gonna be bad code, not up to the PEP 8 standards, but whatever, sue me. Bidirectional LSTM 32 keras layers dot dense and 64 with a ReLU activation. And to prevent overfitting, we are going to add in a little bit of dropout, just 0.5, so 50%, and add our final classification layer with a sigmoid activation. Model, do I have, let me double check here. Looks like I forgot a parenthesis. There we go. Good grief. Delete that line and make our new model. Model.compile. Loss equals binary cross entropy. Optimizer equals atom. Same learning rate. We don't want to change too many things at once. That wouldn't be scientific. Accuracy. history equals model.fit, train data set, not cert, epochs equal 5, validation data set equals test data set, 30 validation steps, and we're just going to scroll up here and copy all of this, visual, yank, and come down and paste. All right, so so I'm detecting a problem here, so I need to modify my sample predict problem, my sample predict. So let's go ahead and pass in a model, call it model underscore, just to be safe, because I'm declaring one model and then another. Want to make sure these scoping issues are not going to bite me in the rear end. I need model equals model, and let's do likewise here. Model equals model, and we'll come up here and modify it here as well, just to be pedantic. And I'm very tired, so this is probably unnecessary, but we want to make sure we aren't getting any funny scoping issues so that the model is doing precisely what we would expect. So let's go ahead and right quit and try running it. Oh, actually, I take it back. I want to go ahead and get rid of the fitting for this because we've already run it. We can leave it. Actually, you know what? Now that I'm thinking about it, let's just do this. And then we will comment this out. All right. And then we don't even need the model equals model there, but I'm going to leave it. All right, let's try it again. Let's see what we get. So remember, we had a 80% and 41% or 42% probability of it being positive. So let's see what we get with the new model. Validation data set. So I must have mistyped something. So let's take a look here. Right there. Because it is validation data, not validation data set. All right. Try it again. All right, it is training. I will let this run and show you the results when it finishes. So, of course, after running it, I realized I made a mistake in the declaration of the sample predict function. Typical, unexpected keyword argument. So let's come here and, let's just get rid of it. Oh, because it's model underscore. Yeah, let's get rid of it because we no longer need it. And get rid of this. Typical. All right. This is one of the situations in which a Jupyter Notebook would be helpful, but whatever. I will stick to Vim and the terminal and Pi files because I'm old. All right, let's try this again, and I'll just go ahead and edit all this out, and we will meet up when it finishes. I've done it again. It's not my day, folks. Not my day. And let us find that there. Delete. Once again. All right, so I have finally fixed all of the errors. It is done training, and we have our results. So probability, this is a positive review, 86%, a pretty good improvement over 80%. What's even better is that the probability of the second review, which was lukewarm, so being positive, has fallen from 41 or 42% down to 22%, almost cut in half. So pretty good improvement with a somewhat more complicated model, and at the expense of slightly longer training. So 87 seconds as opposed to 47 seconds. So I don't know, something like 6 minutes as opposed to 3, not too bad. So anyway, so what we've done here is loaded a series of IMDB reviews, used it to train a model to do sentiment prediction by looking at correlations between the words and the labels for either positive or negative sentiment, and then asking the model to predict what the sentiment of a obviously positive and somewhat lukewarm review was. And we get pretty good results in a very short amount of time. That is the power of TensorFlow 2.0. So I thank you for watching. Any questions, comments, leave them down below. I try to answer all of them. Less so now that I have more subscribers, more views, it gets a little bit more overwhelming, but I will do my best. Speaking of which, hit the subscribe button, hit the notification bell, because I know only 14% of you are getting my notifications, and I look forward to seeing you in the next video.